iwin makes both you and your child happy for life. iwin is to win. Give your child the iwin advantage now.
I welcome you all students into the new class, and I hope you all will excel in the physics subject with the help of my iwin classes. And today I am going to explain one of the problem from laws of motion chapter, and the question is previous year JEE Mains question. The question is this one: a bullet of mass 0.1 kg moving horizontally with a speed of 400 meters per second hits a wooden block of mass 3.9 kg kept on a horizontal rough surface. The bullet gets embedded into the block and moves 20 meters before coming to rest. The quotient of friction between the block and the surface is. Now we are going to calculate the quotient of friction of the rough surface, rough horizontal surface on which the block is placed. And in the calculation, G given as 10 meters per second square. That means use G as 10 meters per second square. And the question is from the JEE Mains 8th April 2023 shift 2. Now the options for this question: first option is 0.9, second one is 0.65, third one is 0.25, and fourth one is 0.5. Now go towards solution. As usual, before going to solution, what is the concept involved in the problem? What happens here? Bullet fires the gun. The bullet mass is given, its velocity is given 400 meters per second. This bullet embedded into a wooden block. This is the wooden block whose mass is 3.9 kg. Right? Now, here what happens? This block is placed on the rough horizontal surface whose quotient of friction mu we are going to derive. Right? So, this is the question. And the concept related to this one is here bullet mass, bullet gun system. That is one thing. One more is friction concept also involved. And to solve this problem, we use conservation of linear momentum. So here, after embedded into the block, the bullet embedded into the block, the system is like this. Here we used 4 kg instead of 3.9 kg. Why? Because here this 4 kg involves two masses. One is mass of the block 3.9 kg plus bullet. Bullet is also inside the block. Let us assume this red dot as the bullet whose mass is 0.1 kg. So which is inside the block itself. That's why this total is considered as 4 kg. The total system mass is 4 kg, which moves with a velocity u dash. And after traveling 20 meters distance on that rough horizontal surface, it comes to rest. Why it comes to rest? This is the rough surface. Means frictional force act opposite to the motion of the body. So due to this retarding force, it comes to rest. So what type of friction it is? The body is under motion, kinetic friction. That is mu k into mg. This mu k is we are going to calculate, right? So this is the explanation of the question. Now I'm going to solve this question. For that, first I'm going to derive the value of u dash, the velocity of the combined block and bullet mass after bullet embedded into block. So that is u dash. That u dash I am going to calculate. For that I am using conservation of linear momentum. So here the velocity is u dash, mass is 4 kg. Here applying of conservation of linear momentum. 0.1 into before hitting the block. The bullet mass is 0.1 kg. Travels with a velocity of 400 meters per second, right? So what is conservation of momentum? Before collision total momentum equal to after collision total momentum. Before collision, mass is 0.1 into velocity 400 meters per second is equal to after collision 3.9 plus 0.1 means 4 kg, right? 4 into, I don't know the velocity, I take it as u dash, this one. So here onwards, what happens? 1 0 cancel here for this decimal and this 4 cancel here. U dash you'll get as 10 meter per second. That means the initial, what is u dash here? The initial velocity of the block and bullet system after collision. So that is 10 meter per second, right? The next one is this one. So here what happens? Applying the conservation of linear momentum, we find just after the collision, this is the before and after. So 0.1 into 400 equal to 3.9 plus 0.1 into u dash. From here onwards, we calculated u dash as 10 meter per second. So now we are going to calculate the quotient of friction, right? So here we apply work energy theorem. What is this work energy theorem? The change in kinetic energy equal to work done by all forces, right? So work done by all the forces is equal to change in kinetic energy. That is the work energy theorem. So work done by all the forces. So what type of force is there? Frictional force mainly here acting. So that is kinetic friction force, which is equal to mu mg, kinetic friction. So I substitute here. So initially the bullet block combined system having 0 u dash velocity, finally it comes to rest. Initially it has u dash velocity. Finally it comes to rest. Comes to rest means final velocity is 0. Means change in kinetic energy I'll write as kinetic energy final minus kinetic energy initial, which is equal to work done by all the forces. Final kinetic energy is 0. Why? Because the block bullet together 4 kg moves with velocity u dash, which is equal to 10 meters per second. After traveling 20 meters distance, it comes to rest. Its velocity becomes 0. Final velocity is 0. Final kinetic energy is 0. Minus initial kinetic energy. Half m. Mass is 4 kg into velocity 10 square 100. So which is equal to work done. Work done by the frictional force. Observe here, mark. Same on the rough horizontal surface. Block is moving along this direction. The displacement is here to here. That is 20 meters. So displacement is along this direction. Whereas force acting is the frictional force, kinetic frictional force, which act along this direction. That means frictional force and the displacement 20 meters both are anti-parallel to each other. That means angle between these two is 180 degrees. Then which is equal to work done is F that is. What is F value? Mu mg into S is this one cos theta. W is F S cos theta. Theta is what? 180 degrees. Cos 180 is equal to minus 1. How this equation changes now? Minus 1 by 2, 4 into 100 is equal to mu value, I don't know, I need to calculate, into m, mass 4 kg, g 10 given in the data, and yes 20 meter, and cos 180 is minus 1, that minus I am writing here. So this minus cancel here, 2 cancel, 200 is equal to, here 200 equal to mu into 40 into 20, right? Here these two zeros here cancel, 1, 2 cancel, then mu I'll get as 1 by 4. This 4 bring to this side. Here 1 is there, 1 by 4, which is 0.25. So mu value is 0.25. Now, once again, I am explaining that. So where we start, F equal to mu mg is the frictional force, and here change in kinetic energy, final kinetic energy minus initial kinetic energy, which is equal to quotient of friction into mg into 20. 20 is the distance. Why negative sign? Frictional force and displacement both are opposite in direction, making 180 degrees. That's why this minus, right? So by simplifying that, we find the mu value as 0.25, right? This is the explanation for that question.